system of linear equations and consistency. In this system of linear non-homogeneous equations, consider the system of M linear equations in n unknowns, where m greater than n or m equal to n or m less than n. A11 x1, A12 x2 plus and so on, plus A an xn, A1n xn is equal to B1, A21 x1, A22 x2 plus and so on, A2n xn is equal to B2 and so on, AM1 x1 plus AM2 x2 plus and so on, AMN xn is equal to Bm. The above system of equations can be written in the following matrix form. Coefficients of the first equation, coefficient of x1 a11, coefficient of x2 a12 and so on, coefficient of xn a1n, in the second equation, coefficient of x1, coefficient of x2 and so on, coefficient of xn and so on. In the mth equation, coefficient of x1 am1, coefficient of x2 am2, coefficient of xn amn, the unknowns x1, x2 and so on, xn, constants in the right hand side b1, b2 and so on, bm. If you can multiply this first row, first column, we get A11 into x1 plus A12 into x2 plus and so on A1n into xn is equal to B1 is equal to B1. Similarly, second row and so on mth row. We get the above system of equations. This can be written as Ax is equal to B. Ax is equal to B, where A is equal to where A equal to A11, A12 and so on, A1n, A21, A22 and so on, A2n and so on, AM1, AM2 and so on, AMN is called the coefficient matrix, is called the coefficient matrix, since these are all the coefficients of x1, x2 and so on xn in the given linear system of equations. So it is called coefficient matrix. X is equal to x1, x2 and so on xn is the column matrix of n unknowns, and capital B is equal to B1, B2 and so on Bm is the column matrix of m constants. M constants. This is the matrix form of the above system of linear equations. First of all, why this system is linear system of equations. Here the degree of x1 is 1, degree of x2 is 1 and so on degree of xn. The degree of each unknown in this equation is 1. So this is called linear equation. We have more than one equation here. So this is called system of linear non-homogeneous equations. If the right hand side at least one b1 is not equal to 0, this is called non-homogeneous system of equations. If all b1, b2 and so on bm is equal to 0, then the system is called homogeneous system of equations. Now here we are discussing non-homogeneous system of linear equations. Now this augmented matrix, augmented matrix. What is meant by augmented matrix? The matrix A, B obtained by placing the constant column matrix B to the right of A is called the augmented matrix. So the augmented matrix is formed by writing A and the matrix B side by side. Then it is called augmented matrix. That means we are placing the constant column matrix B to the right side of the matrix A. Combining these two matrices, the resultant matrix is called augmented matrix. Next, what is the solution of the system of equations? Solution of the system of equations. System of equations. Any set of values, any set of values of x1, x2 and so on, xn, which satisfies the given system of equations is called the solution of the system of equations. System of equations. What is meant by the solution of the system of equations? We already seen the linear system of equations. Here a11x1 plus a12x2 plus and so on, a1 and xn equal to b1, a21x1 plus a22x2 plus and so on, a2n xn equal to b2 and so on, am1x1 plus am2x2 plus and so on, amn xn is equal to bm. Now solution for this system of equations. Any set of values of x1, x2 and so on, xn satisfies this system of equations. Satisfying means if we substitute the values of x1, x2 and so on, xn in this equation, so the value in the left hand side must be equal to the value in the right hand side. Then we can say that the system of equations satisfying by these values, therefore these values are solutions of this equation. If these values satisfies all the equations in this system, then this is called the solution of the system of equations. These values must satisfy each and every equation of the system of equations. Then the solution is called solution of the system of equations. Next, consistency and inconsistency of the system of equations. Consistent and inconsistent. Consistent and inconsistent. If the system of equations has one or more solutions, then the system is called consistent. Then the system is called consistent. The system of equations may have one solution or more than one solution. In this case, the system is said to be consistent. If the system of equations has no solution, then the system is called inconsistent. So if the system has no solution, then we say that the system is inconsistent. And now, working rule to find the solution of non-homogeneous linear system of equations. Working rule to find the solution of the system of linear non-homogeneous equations. Ax is equal to b. How to find the solution of the linear non-homogeneous system of equations? Ax is equal to b. We first write the augmented matrix. Augmented matrix A, B. Reduce the augmented matrix A, B to the echelon form. We already explained what is an echelon form of the matrix. Third one, observe the rank of A and rank of augmented matrix AB. If rank of A less than rank of AB, then the system of equations has no solution. Has no solution. Or rank of A not equal to rank of AB, then the system of equations has no solution. If rank of A equal to rank of augmented matrix AB, which is denoted by R, and this is equal to n number of unknowns, then the system of equations has unique solution. So if rank of A is equal to rank of augmented matrix, the common rank is denoted by small r, and this common rank is equal to number of unknowns in the given system of equations, then the system has unique solution. And fifth one, if rank of A equal to rank of augmented matrix AB is equal to R, which is denoted by R, is less than the number of unknowns, then the system of equations has an infinite number of solutions. In this case, we have to assign arbitrary values to n minus r of unknowns. So if rank of A is equal to rank of augmented matrix, the common rank is denoted by small r. If it is observed that this is less than the number of unknowns, then the system has an infinite number of solutions. It is a theoretical proof. So here no need of proof. We have to learn only the condition. In this case, the system has infinite number of solutions. So here we have to assign arbitrary values to n minus r of unknowns. Remaining r unknowns can be expressed in terms of n minus r unknowns. So we get infinite number of solutions. This is the procedure to find the solution of the linear non-homogeneous system of equations Ax is equal to B.